Okay, welcome to the Quadratic Formula and Discriminant podcast. You've been solving quadratic equations by completing the square and practicing that method. So now you're going to learn how to solve quadratic equations using the quadratic formula. And the quadratic formula was derived when somebody completed the square of the standard form equation, this one here. And the solutions are in the form of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now let's look at how we use that quadratic formula. So notice in this example that the equation is not in standard form, so that's our first priority. And remember that standard form is ax squared plus bx plus c. So we want to get this equation in that form. So 3x squared, sorry, ignore that extra long 3 line, plus 7x. We're going to subtract our 13x. We need to subtract 24. Okay, and now we have 3x squared minus 6x minus 24. So now we can find our a, b, and c. Our a equals 3, our b equals negative 6, and our c is negative 24. And now that we have a, b, and c, we can use our quadratic formula. So I'm going to put the quadratic formula over here so you remember that. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b is plus or minus the square root of b squared minus 4 times 3, our a is 3, times c, all over 2 times 3. And I wrote it out very specifically so you can see all of the steps on this first example. So a negative 6, that's positive 6, plus or minus the square root of 36 minus 4 times 3 times negative 24. We get plus 288. Sorry about that. That's 36 plus 288 over 6. And now we can continue up here. We have 6 plus or minus the square root of 324 over 6. And that equals the square root of 324 is 18 divided by 6. So now this gives us two solutions. We have 6 plus 18 over 6, and we have 6 minus 18 over 6. So 6 plus 18 over 6, 24 divided by 6, x equals 4. And this one here, negative 12 divided by 6, so x equals negative 2. And those are our two solutions. So when we applied the quadratic formula to this equation, we got two real solutions. So I'd like you to make sure you have this example down in standard form, just like we have there, because we're going to be using that later. So let's look at another example. Okay, so in this second example, we're going to solve the equation using the quadratic formula again. Remember, you have to put this in standard form, so let's go ahead and do that first. We have 16x squared minus 23x minus 17x plus 25. That equals 0. Now, 16x squared minus 40x plus 25. And now we can find our A, B, and C. B equals negative 40 and C equals 25. Now that we have our A, B, and C, we can apply the quadratic formula. So again, I'm going to write this out here so we know what to plug in where. And a negative 40, that's going to be positive 40 plus or minus the square root of b squared minus 4 times 16 times 25 all over 2 times 16. So now, let's put all that together. We have 40 plus or minus the square root of 1600 minus 1600. Just ignore that mark, sorry about that. They're over 32. And 1600 minus 1600 is 0, and the square root of 0 is 0. So, we're just left with 40 over 32. And we can simplify that to 5/4. Sorry, ignore that mark too. So, our solution is x equals 5/4. And this equation, using the quadratic formula for this equation, produced one real solution. Where our last example, we had two real solutions. This one only produced one real solution. Let's look at one more example. Oh, great. Whew, this one's already in standard form. So, we can find our A, B, and C values. A equals 1, B equals negative 6, and C equals 10. And when we plug that into our quadratic equation, we get a negative 6, which is positive 6, plus or minus the square root of b squared. Negative 6 squared is 36, minus 4 times 1, 4 times A, so I'm just going to leave the 4 times C, which is that there, over 2A, but since A is 1, all we put is the 2. And now, we have 6 or minus the square root of 36 minus 40, which is negative 4 over 2. Okay, so since we have a negative under the square root there, we're going to have to use I. And we talked about that when we did complex numbers. So, the square root of 4 times the square root of negative 1 over 2. Remember, negative 1 equals I, or excuse me, the square root of negative 1 equals I. So now, 6 plus or minus the square root of 4, which is 2, and the square root of negative 1 equals I over 2. And that equals 3 plus or minus I, because 6 divided by 2 is 3, and then the 2 divided by 2 is 1. So 3 plus or minus I. So our solutions, x equals 3 plus I, or x equals 3 minus I. So because this uses imaginary numbers, our solutions aren't real solutions. This quadratic equation produced two imaginary solutions. Oops. Two imaginary solutions. Okay, now let's talk about the discriminant. In the quadratic formula, the expression b squared minus 4ac is called the discriminant. So, if you have the quadratic formula here, this part under here is the discriminant. And we use the discriminant to find the number and type of solutions. Do we have two real solutions, one real solution, or two imaginary solutions? So we're going to use those equations from examples 1 through 3 in standard form on this next slide. So make sure you have those. So from example 1, our equation was 3x squared minus 6x minus 24 equals 0. Example 2, it was 16x squared minus 40x plus 25. And example 3, x squared minus 6x plus 10. So let's find our a, b, and c for each of these examples and then calculate our discriminant. So a equals 3 here, b equals negative 6. C equals 24. And remember, our discriminant is b squared minus 4ac. So b squared is negative 6 squared, 36, minus 4 times a times c. And that gives us 36 minus plus 288. Which equals 324. Okay, so that's the value of our discriminant for that example 1 we did. Let's look at example 2. A equals 16, B equals negative 40, and C equals 25. So our discriminant is negative 40 squared minus 4 times A times C. And that's 1600 minus 1600, which equals 0. And finally, example 3, a equals 1, b equals negative 6, and c equals 10. So our discriminant, b squared minus 4 times a times c, 36 minus 40, negative 4. Now remember, example 1, we had two real solutions. That R stands for real. Example 2, we had one real solution. In example 3, we had two imaginary solutions. Sorry, ignore all those little marks there. Okay, so notice that this discriminant is greater than 0. This discriminant equals 0, and this discriminant is less than 0. These observations hold for the general quadratic equation in standard form. So if the discriminant of a quadratic equation in standard form is greater than 0, we're going to get two real solutions. If our discriminant equals 0, we'll only have one real solution, and that means that min or max of our quadratic graph is somewhere on the x-axis. And if our discriminant is less than 0, we're going to have two imaginary solutions. So our graph our graph is not crossing the x-axis. So, to put that all in an easy to read table for you, if our discriminant is greater than 0, 2 real solutions. So if our discriminant is greater than 0, we know we have 2 real solutions. If our discriminant is equal to 0, we have 1 real solution. And if our discriminant is less than 0, so negative value, we're going to get 2 imaginary solutions. Sorry. And that means it's going to have that I value in it. Okay, so let's look at what the graphs of the equation would look like depending on the value of our discriminant. So, if it has 2 real solutions, if the discriminant's greater than 0, our graph is going to cross the x-axis in 2 places. And this could go down as well. This graph could be opening down as well, as long as it's crossing the x-axis in 2 places. Okay, if we have 1 real solution, if our discriminant equals 0, our graph is touching the x-axis in 1 spot. And again, that graph could be opening up. And if we have 2 imaginary solutions, then our graph isn't touching the x-axis and has no x-intercepts. So there we have it, the quadratic formula and the discriminant. And remember, when we apply the quadratic formula, we have to put our equation in standard form. And the discriminant tells us how many solutions and what kind of solutions. 2 real solutions, 1 real solution, or 2 imaginary solutions. Thank you, and we'll see you in class.